Alright, in the previous lecture we have looked at deletion of a node from circle single linked list. Now in this video we will look at how to delete entire circle single linked list from the memory, and we will implement it in practice. Now the steps here are very simple because all we have to do, we have to delete the head reference, tail reference and last node's reference. So here the first step is we are going to set head reference to null. Now if I set head reference to null, the link between head and first node gets destroyed. Now in case of single linked list, after setting head to null, the first node gets destroyed because there is no link to this first node over here. But in case of circle single linked list, this is different because in this case we have a reference to first node over here. Now this reference comes from the last node, so this means that the next step that we are going to do, we have to set last node's next reference to null. Now if I set last node's next reference to null, the link between last node and first node gets destroyed. Now after doing so, now the first node is not referenced by any node. This means that garbage collector can come and delete this node from the memory. Now after deleting it, the second node becomes eligible for garbage collection because in this case there is not any node that is referenced to second node, so this means that second node can be deleted by garbage collector. Now after deleting second node, the third node becomes eligible for garbage collector, so garbage collector continues to delete this node as well from the memory. Now when it reaches the last node, it cannot delete it because in this case last node is referenced by tail. Now the final step over here, we have to set the tail reference to null. Now after setting it to null, in this case the link between tail and the last node gets destroyed. Now after this link is broken, this node, the last node, becomes eligible for garbage collection, so the garbage collector comes and destroys this from the memory. Now with this, we have successfully deleted circle single linked list from the memory. Now in this case, the steps are very simple. All we have to do, we have to set head reference to null, last node's reference to null, and tails to null. Now after doing so, all nodes over here become eligible for garbage collection one by one, starting from the first node until we reach the last node. Now this is how the logic behind the deletion of an entire circle single linked list works. Now based on this logic, let's implement it in practice. Now here inside this circle single linked list Java class, we are going to implement our last method. Now the last method is responsible for deleting circle single linked list from the memory. So that's why I'm going to declare our method like this: public void delete circle single linked list. So this method will not take any parameter because in this case we don't need any parameter. We are just going to delete the entire circle single linked list from the memory. So as always, the first thing that we are going to do, we are going to check that if head equals to null, so this means that circle single linked list does not exist. So I'm going to print out to the console saying that circle single linked list does not exist. The circle single linked list does not exist. Now after doing so, if our circle single linked list exists, then in this case, in the else condition, we are going to delete it from the memory. Now here the first step is we are going to set head reference to null. Then the next step is we need to set the last reference, next reference to null. Now to do so, we need to access the tail because tail reference to last node. So if we access tail.next, we are going to access the last node's next reference. So I'm going to set it to null as well. Then at the end, I'm going to set tail to null as well. Then I'm going to print out to the console saying that the circle single linked list has been successfully deleted. So here I'm going to put our message like this: system out print. So the message will be CSLL, which stands for circle single linked list has been deleted. Now after doing so, we have successfully implemented our method. So in this case, as we said before, the steps are very simple. All we have to do, we have to set head reference to null and last node's next reference to null and tail reference to null. Now let's see how this is working in practice. So here we have created our circle single linked list like this. Then we have inserted 4 elements over here. Then by using traverse method, we are printing out to the console this circle single linked list. Then we are going to call this delete circle single linked list. Then we are going to call traverse method to see the result one more time. Now if I run our code, you will see that first is printing out to the console the circle single linked list that we created over here. Then the next message is the circle single linked list has been deleted. So we have called this delete method over here, so it's deleted. Then if we call traverse method again, it says that circle single linked list does not exist. So we have successfully deleted this circle single linked list from the memory. Now our method works the way that we want. Now let's see what's the time and space complexity for this method. So as always, we are going to start from the first line of code of this method. So in this case, in the first line, we have if condition in which we are checking head value and printing out to the console this message. So this part of code will take O1 time complexity. Now in the else condition, we are setting head to null, the last node's next reference to null, tail to null, and printing out to the console this message. Now each assignment over here takes O1 time complexity because these are simple assignments over here. We are just setting them to null, and at the end we are printing out to the console this message, and printing out to the console will take O1 time complexity. Now if we combine all these complexities over here, we will get O1 time complexity. Now the space complexity is also O1 because here an extra memory is not required to perform this operation. All we are doing, we are deleting all nodes of the circle single linked list from the memory. That's why space complexity is O1. Now with this, we have come to the end of this lecture. So in this lecture, we have talked about how can we delete entire circle single linked list from the memory, and we have implemented it in practice. So hopefully everything is clear about this method over here. So see you in the next lecture.